permutations and combinations, and the first thing you have to talk about with permutation, you're counting up different ways things can be grouped. So the very most simple way things can be grouped is just if you pick like a Chinese menu approach. You pick one from column A, one from column B, and one from column C. How many different ways can we come up with a different grouping? All right, and we call that way to get different groupings the fundamental counting principle. And all that says is, if you want to know, like the most famous problem, the one you probably did in Algebra 1, was if you have, you're at a buffet and there are 3 salads, 4 meats, and 2 vegetables, how many different meals can you make? Or if your closet has 3 skirts, 4 blouses, 2 pairs of pants, and 2 pairs of shoes, how many different outfits can you make?
Oh, I hate these.
Yeah, those are, no, they're easy.
No, they're impossible.
Okay.
What?
Okay.
Tyler's in the class.
All right, so the fundamental counting principle says that all you have to do is add up how many items in each column, okay, and then multiply them together. And that's the total number of groupings you can do. And I could prove that to you, but it would take the rest of the period, and we have other stuff to do. So you're going to have to take my word for it.
Wait,
all right, so
you add them all up together, and
so no, you add up all of the choices in each column. So let me give you an example. So I have pizza that I have the choice of 3 different crusts, 4 different cheeses, 5 different meats, and 8 different vegetables. Okay, and I want to know, like I'm in charge of the advertising, I want to know how many possible different pizzas could you make. Okay, so what you do, there are 4 choices, right? 3 crusts, 4 cheeses, 5 meats, 8 vegetables. And so to figure out how many total combinations that would make, I just multiply them together.
12,
60 times 8 is 480, right? So that would make 480 completely different pizzas. Okay? Last period, I still can't figure out how many, like I can't find all 8 vegetables. I'm not sure who wrote this one. Mrs. Hubman and I did it, so she must have. But I can't think of 8 vegetables that go on pizza. Yep, I did.
peppers.
Well, we don't have time to do it right now. We tried to do it last year and we took some time. Okay.
Mushrooms.
Okay. All right. Here's another example, kind of a famous one with license plates. You're still going to do the same thing. For each, you're going to make a blank for each column, okay? So if we have a license plate that has 1 letter, then 2 numbers, and then 3 letters, okay, so that's letter, number, number, letter, letter, letter. How many different license plates can we make if the digits can be repeated? So that means if you could have A99AAA, like you could just repeat them all. Okay? So how many choices in letters in the first column do I have? 26. How many numbers?
9.
10. Because 0. 10, and then 26, 26, and 26.
So the numbers run from 1 to 10, basically.
0, 1, 2, 3, 4, 5, 7, 8. All right. So I multiply all those together. Now, if I were part of the BMB, I would say, okay, is that enough? Like, do I have enough license plates for everybody to have one? Like, this is kind of what they do when they decide if you should have 3 numbers and 2 letters, or 3 numbers and 3 letters, or whatever. They basically what they're doing is there's exercise just to make sure they get enough. And so how many license plates is that?
6. No, it's like 6.
I think it's like 45 million.
676.
45,697,000.
Is that enough?
Yes, it's enough for Ohio. So I think there's less than 45 million cars. But hopefully if you worked at the BMB, you'd know what that number was. All right, now, this is sort of like without replacement. If I had the same setup for license plates, and only this time I'm not allowed to repeat a letter or a number. Okay? All right, so the first letter, how many choices do I have? 26. The first number, 10. But the second number, I've already used up a number, so I can only use 9. How about this letter? After every blank, I've used up a letter. So it goes down. So the first time I had 26 choices, now I only have 25, then I only have 24, then I only have 23.
32,292,000. Sorry, I had to do that.
Okay? All right, so that's the fundamental counting principle. You just multiply, and we've kind of used that yesterday, right? With probability, when we multiplied them all together, all the different probabilities, that's kind of what we're doing. All right. All right, then we get into permutations, okay? Permutations are grouping still, just like we did with the pizzas and the license plates, but we're grouping smaller groups of them. And permutations are when order matters. So like if I had, my student council has 40 kids in it, I want to know how many different ways I could have a president, a vice president, and a secretary, okay? So every group of 3 kids could be 3 different orders, right? Because I could have Nick is the president, Alexa's the vice president, and Tyler's the secretary, or I could have that Tyler's the president and Alexa's secretary and Nick's the vice president, or I could have Alexa's the president, right? I could have, so every single group of 3 would be 3 different orders. So for permutations, I have to take that into account, that arrangement of objects in a given or specific order, okay? So the order matters, okay? I always think of P, because when we put in our calculator, we're going to use the P button, but the P for position. It matters what position people are in, okay? All right, and on your calculator, on the formula is n factorial. Does everybody remember what factorial is?
No. Like 1 times 2 times 3 times 4 to get to your number.
It's the other way around. Yeah, you start at the highest, like 10 factorial would be 10 times 9 times 8 times 7 times 6 all the way down to 1. You just start at whatever that number is and you multiply all the numbers underneath it. Okay? That's what factorial means. So to count, like if I had 40 kids in student council and I wanted to know how many groups of vice president, president, secretary I could have, I would do 40 factorial over 40 minus, and the groups are in groups of 3. So 40 minus 3 factorial. Okay, now before calculators, the way I would have done it is 40 factorial over 40 minus 3 factorial. And it looks really awful, but it's not. Because you think about it, 40 factorial means 40 times 39 times 38 times 37 times 36, all the way down. Okay? And 40 minus 3 starts at 37. So it's 37, 36, all the way down, right? So the 37, 36, all the way down, they start canceling out. So really, the answer is just 40 times 39 times 38. So it's not that awful if you had to do it by hand. But you don't, which is nice. You have a button on your calculator, and this is on either scientific or graphing, doesn't matter.
Factor 11.
I'm sorry? What? So for permutation, so let's say I want to know how many groups of president, vice president, and secretary I can have in my student council. So I'm doing a permutation, because order matters, of 40 kids taken 3 at a time. Okay, that's what it would look like. So on my calculator, I'm going to type in the 40 first, because this is the button I'm going to find, and so I got to tell it what n is, and I got to tell it what r is. N is the total group, r is how many are going to be in each small group. So I do 40, then I go to math, over to probability, and on a scientific calculator, it's catty-cornered from the second function button. It just says PRB. Okay, so I go to PRB, I go down to NPR, hit enter, and then 3. And I hit enter.
Oh my gosh.
And so it's 59,680.
Why did I have this on ACT when I took this?
Okay?
Yeah, I'm pretty sure this was on.
Yeah, it was. They said that people keep telling me there were tons of them. All right.
I can't use that. I'm so stupid.
All right. So let's do a couple of these examples. 8 teams are competing in a baseball playoff. So there's 8 total teams. I want to know how many ways they can finish first, second, third, fourth, fifth, sixth, seventh, eighth. So what would that be?
8 factorial.
Nope. There'd be a P. How many groups am I starting with? 8. How many am I worried about getting in order?
3.
Nope, not 3 at a time. 8, right. 8 teams, and I want to know how many different ways they can all finish. So 8, P, 8.
40, 32.
Okay? Okay, now, if we have permutations with repetition, and what that means is, like if I said, how many different ways can we put the letters of this word in order? You couldn't tell the difference between those E's, right? So it's going to affect the number of words we can put, or the number of orders we can have for these words, because having E come first and this E come second, wouldn't that be the same as having this E come first and that E come second? So there's repetition. That's why we call it permutation with repetition. Okay? So if to do that, I got to go back to my original formula. To figure out how many ways you can order those letters with repetition, you start out with n factorial. So like an even, how many letters are we talking about? 4. 4 letters in even. So I do 4 factorial. Okay? And then I write every single letter at their number of occurrences. So V shows up once, 1 factorial. N shows up once, 1 factorial. But E shows up twice, so that'd be 2 factorial. So I've got 4 factorial over 1 factorial times 1 factorial times 2 factorial. So that'd be 4 times 3 times 2 times 1 over, and 1 and 1 factorial is just 1, so I'm going to ignore it, over 2 times 1. So that's 24 over 2 is 12. So there's 12 ways to write even. Okay? Now tell. I just stepped down. So if I'm doing 11 factorial, I do 11, and then I go to factorial, and then I divide it by,
32.
48.
48 times.
And I get 831,600.
What did I do wrong here, folks?
Okay?
Because I plugged it in factorial.
Then we have combinations, and that's when order doesn't matter. Okay? So you're doing it without regard to order. You doesn't care. So basically what that's saying is, with my student council, if I have 40 kids in student council, how many committees of 3 could I make? Okay? So these 3, if I put them in a committee, there wouldn't be 3 different ways to do that.
Right.
The 3 of them just makes 1 committee, no matter which order they pick them in, right? So combinations are when order doesn't matter. Okay? Permutations, position matters, combinations does not. Okay? The only difference between the original formula is it's n factorial over n minus r factorial, so it's just like permutations, but then you multiply by r factorial again. R is the number of groups you're going to make, like groups of 3 or groups of 2 or whatever. Okay? So you are picking 7 books from a stack of 32, and the order of the books you choose doesn't matter. If you're just sticking them in your backpack and take to the beach or whatever, then you have, instead of PR, you're having NCR. How many total? 32, right? 32 altogether, and you're picking them in groups of 7. So it's going to be 32, choose 7. Okay? So you just type that in your calculator. Yep. That is it. The local movie of